All right. So let's look at page 11, exercise 8. So this was another one of your homework problems. And it says a group of 9 people, some adults and some children, went to a movie theater. Adult admission was $8 and child admission was $5. The amount charged was $55. Could this amount be correct? Well, yeah, I mean, if there's some kind of like sales tax or something, but they didn't tell us any of that. I mean, I think we're just meant to assume that the price that you get charged for the tickets is gonna that your subtotal is gonna be your grand total, right? We're supposed to kind of assume that there's not gonna be any kind of like service fee or or something weird like that. So let's think about this. I'll tell you one incorrect solution that students often come up with is they say, oh yeah, 5 adults and 3 children, right? They're thinking, so oftentimes they'll say 5 adults and 3 children. And the reason they think that is because they've done some guessing and checking, which is fine. Um, but 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 then they say, so they've done some guessing and checking, and they say, all right, 5 adults, and each adult is charged $8, and then 3 children, and each child is charged $5. And if you add that up, 5 times 8 is 40, and 3 times 5 is 15, and 40 plus 15 is $55. So a lot of times students will come up with that answer. They'll say, oh yeah, $55. That's great, right? So that adds up to be the total that we were charged. Now the problem with this is that 5 adults and 3 children does not make 9 people. That only makes 8 people. And we were supposed to have 9 people, right? So you reread the problem from the beginning. It says a group of 9 people, some adults and some children, went to a movie theater. Adult admission was $8 and child admission was $5. The amount charged was $55. So this won't work, right? This won't work because it only adds up to 8 people, and we need 9 people, right? So what can we do? Well, one way that is kind of a nice way to solve this particular problem is you could set up a table. So you could do something like this. You could say number of adults, number of children, and then amount charged, right? And you can just kind of make this table and um, try to find a combination of adults and children that add up to 9, right? But where the amount charged is equal to $55. So you might start and say, well, let's say that there are 9 adults and 0 children, right? That would add up to 9 people in total. Now, how much would they get charged? They would get charged, and I don't have enough space to show it here, but what I'm going to say, they would get charged 9 times $8, right? Because each of these 9 adults gets their ticket it costs $8. So they would have 9 times 8 plus 0 times 5, right? So 9 times 8, $72. That's how much they'd get charged. Okay, that obviously doesn't work. It's too much. So maybe since adults are more expensive than children, we obviously need fewer adults if we want the amount charged to decrease. So maybe we could try 8 adults and 1 children. Then that adds up to 9, right? And let's see, 8 times 8 is 64. 1 times 5 is 5. 64 plus 5 is 69. So they would get charged $69, right? That's still too much. We're trying to find a total price of $55. So we could keep guessing and checking like this, right? So if you kept going, eventually you would run into this scenario. You would run into, if you have 4 adults and 5 children, 4 times 8 is 32, 5 times 5 is 25, and 32 plus 25 is $57. So they would get charged $57. That's still a little bit too much, but we're really close now, right? So let's go 1 fewer adult. Let's go 3 adults and 6 children, right? This still adds up to 9 people. And how much do they get charged now? 3 times 8 is 24. 6 times 5 is 30. 24 plus 30 is 54. So when we had 4 adults and 5 children, the amount charged was $57. When we have 3 adults and 6 children, the amount charged was $54. It doesn't seem like it's possible for us to get a charge of $55, right? So it seems like the answer to this question, right? So the question asked us, could this amount be correct? And the answer is no, right? It's not possible, right? It's not possible. Here's another way to see that. So let me see if I can go to the next page. So here's another way to see that. So you could set up you could set up a system of equations. You could say, let A be the number of adults, right? Let C be the number of children. Okay, and if that's the case, well, one thing that we know right off the bat is that A plus C has to equal 9, right? Because the total number of people has to be 9 people. So the number of adults plus the number of children has to equal 9. The other thing we know is that adults get charged $8, children get charged $5. So the amount charged would be 8 times the number of adults, right? Because each adult gets charged $8, plus 5 times the number of children, because each child gets charged $5. Okay, so this is the total amount that you're going to get charged. And we know that that should equal 55, right? So there's a system of equations that you could solve. I'm not going to go through all the nitty-gritty details, but if you solve this system, what you end up with is A equals 3 1/3 and C equals 5 2/3. So in other words, the only combination of adults and children that will get you $55 is if you had 3 1/3 adults plus 5 2/3 children, right? So obviously this is not possible. How can you have 1/3 of an adult or 2/3 of a child, right? So that doesn't work out. But it corresponds nicely to what we saw in the chart that we made up here, right? Because if we had 4 adults, the price is too high. If we have 3 adults, the price is too low. So the number of adults should be somewhere between 3 and 4. And sure enough, we're seeing that the number of adults would have to equal 3 1/3 in order for this to work out. Anyway, so the answer is no, this is not possible. Okay. So I think that's all I have to say about that one. Oh, come on. I always have to remind myself how to stop recording.